Hello again, it's Mr. Pete. Welcome back to Studio G, and this is tips number 1001, and it's part 8 of a video series I've been making about the little 618 Atlas lathe, and I think some of you have been enjoying it. There'll probably be a lot more, although it is now September 10th, 2024, and it's pretty darn cold out here. So I will not be making many more videos in my cold studio. I will be reverting to the warmth and sanctity of Studio B. You might find it interesting in today's video where I am going to use the South Bend Franken mill to construct what I'm going to make here. And the subject of the video is to make a tool post that will fit onto the Atlas lathe. So let me talk about that a little bit. Stick with me, it'll be a long video. And yes, I will be using the forsaken and forgotten and seldom used South Bend Franken mill. And I would like to thank Mr. Jim Files for sending me an excellent copy of the Atlas parts list, which I did not have before, and this will be very helpful, and it even included what do we got, about 8 pages, a chart. The same chart, in fact, that is in the book and on the gear guard. I hope you watched the previous 7 videos in this series. Astute observers will note that in the 1966 Sears Craftsman tool catalog, they show the 618 lathe, but it is sold without tool holders. In fact, in some of the pictures, they show a 3/8 high-speed steel tool bit held in the tool post without a tool holder. If you wanted tool holders, right and left hand, you had to order them separately, and you could pay by the month. If you watched my previous videos in this series, you might remember that I had a lot of trouble using this tool holder, getting the tool low enough, because it just ends up way, way above center without tilting it down considerably like this. So again, let me show you something else here, is that in the Sears catalog, and I'll show you that in a second, they originally showed that all you got to do is hold a 3/8, this isn't sharpened, a 3/8 square tool bit in the tool post, and it pretty much is on center. But this tool is just like overly sized for this machine. In fact, it really needs a 3/16 square, doesn't it? So what am I going to do about it? Well, for now, let's just set that aside, and remember that this is a homemade compound, although now I'm not so sure. Some people said that Atlas Clausing up in Michigan, in later years, rather than sending you a cast iron one, was sending you a machined one. So, and the job is this is very, very well done. So maybe it did come from Clausing. So what is my solution? Now, you probably haven't watched it, but in my Unimat series, you will see that a man from Vietnam sent me a wonderful gift of that bamboo cabinet and all of that, but he included 3 or 4 of these tiny little tool posts. But this is for the Unimat, so it's really too small. But I would like to construct or make or machine one like this, only just a little bit larger in scale with this machine and with the proper T-bolt. So that's exactly what I'm going to do in this video. So how will I go about that? Drawing this up or scaling it or whatever so it is the right size. So what I do in my thought process is I make a little wooden model. Now, I had almost a completed one, and I lost it. I spent over an hour looking everywhere for it. I don't know what it is, where it is, but I made it. This one's pine, but I made one out of beechwood to get the size. And then after that, I made a prototype out of aluminum. And this one works pretty darn well, but there are just a few dimensional changes that I intend to make. And the final one shouldn't be aluminum. It should be made of steel. And this will hold both 3/16 and 1/4 inch square tool bits. However, the problem with this type of tool post is there's no real adjustment for height. So that could be problematic. So a fellow would have to shim it either underneath, but I like to use little brass shims under the tool bit and raise it to the exact correct on-center height, but that is strictly trial and error, and also it depends on how you sharpened your tool or resharpened it and how high the actual 3/16 tool is. So we'll get all into that, and I've already talked a little bit too much. I ordinarily do not make drawings. I work out of my head. Sometimes I make little notes or a tiny sketch of something, but I tend to avoid that to speed things up, but it may not speed things up. But anyway, I had to start with a very large block of aluminum because I want this to be approximately 1 1/8 square, although this one isn't. So I started with a substantially large piece of steel that I think is 1.5 inches thick here. It was much bigger, and I sawed it out. It took a long time to get down to the blank size here, but this is 1 1/8 square, I believe, and 1 5/8 long. 1 1/8 by... No, it's 1 1/4 high, if anyone would make this, which is a long shot. So now the blank is ready to lay out and to machine. So it will be setting on there like this, of course. So let me put the die toward the headstock. Now what I'm going to do here first is to establish the center of the lathe, and I'll do that by putting a scriber in the 3-jaw chuck. I'll be right back. I am now officially unable to make videos in the morning unless I become stimulated. But before again, it's always before. Get to the point, tubalcain, but no. First of all, just this morning, and many of my videos I make months ahead of time, but just this morning I watched Keith Rucker's video on taking apart a 4-jaw chuck, and he did an admirable job, but now people are going to say that, oh, you just copied Keith on that. But no, I made mine long before his, and I'll show you a little picture of that right now where I cleaned that up. Not that it matters, but some people think I'm paranoid, but really I'm not, but they may be listening. So with the dicum applied and a very, very sharp scriber right here, what I'm doing is marking it. Oh, that sure didn't show up. It does to me, though. I'll do it a little harder off camera. Well, that was on camera, wasn't it? By the way, it took me over an hour to mill this down and make it square and to the size I wanted, but I am sparing you all of that. I did that on the Bridgeport, actually, and I like to mark top or back, whatever. Now that I have that center line established, and that'll be the center, you understand here when I compare it to this one. So I have to measure half of this, which would be, what, 3/32 down, and find that line and mark it right here. And I'm going to make it 1/4, I'm going to use a 1/4 inch end mill, so that a 1/4 inch tool bit will fit in here as well as the 3/16, but I'm more concerned about the smaller size. I just had a bright idea on how to get that line 3/32 farther toward the bottom. I put 2 3/32 drill bits on the compound, and I will put the work on that and scribe it. Understand what I'm doing? So it is the bottom line now that is not complete that will be the layout line where well, this is the wrong size end mill, it's a 3/16, but that will be the bottom of where I am milling when I set it up on the Franken mill here presently. By the way, when Keith Rucker oiled and greased his big chuck, he's going to need to run that machine at 10,000 RPM for 8 hours to sling all of that oil and grease out of there, or he will truly wear the shoulder stripe of shame. No offense, Keith, I'm just having fun. I love you. You know, they must have made very, very few of these South Bend vertical mills, because there's really almost nothing about them on YouTube other than what I put on there. A few others, but some of them weren't very long videos. But anyway, I'm using a real small vise here, which I got from Wayne. Hi, Wayne, and Wayne's going to come and visit me here for Arnfest along with Palmer. But anyway, I've got a parallel, and this is all laid out and ready to go. So I'll lay it on the parallel and tighten up like so. Now I'm going to locate the cutter here in relationship to the work using the edge finder and doing a little math so that I'm right on that line. But it probably would be good enough just to bring the cutter down. You know, it's probably not that critical. But I'm trying to show you sometimes the correct ways, and I want it to be 1/4 inch deep. This is a 1/4 inch tool bit, so that it's about flush and in alignment with the screws. I hate to promote anything from the big freight store, but this was $8 or $9. I actually love it. It's got a magnet on the bottom, which will interfere with the chips greatly, but I can put that anywhere I want and tilt it, turn it, plus it can be held by hand and can be held by a hook, and it even has a little magnet right here if I would want to fasten it to something like that. So get yourself one of these. I know they probably got a life of 3 months, but at $8, who cares? Costs more than that for a cup of coffee. Sorry to say that the Frankenmill no longer has a working spring in the quill, so I have to take that into consideration. But I think I'll place an order later today to South Bend Lathe for a new spring. Not. Well, using the edge finder and all of that, I am right on the edge of that line. Actually, I'd like to back it up a little bit, so I take a cleaning cut with climb milling so that I get a nice surface on that. I don't want to get into details on that. So I'm going to stay away from the line a little bit, so I got about 5 thousandths to clean up on the final pass, and I may not show that. I will cut this groove or slot in about 5 passes because I do not want a slender end mill to more or less drift a little bit on me. Way too slow. I gotta speed this thing up. Okay, that's a little better. Get your safety glasses on. Practice all your safety rules when you're working. It still could be a little faster than that, but it'll have to do. Okay, this is the 5th and final pass to depth, and then I'll take those little climb milling passes on both sides. That will make it 250 thousandths deep. You know what? I'm not able to get the speed that I want. I fiddled around off camera with the belts in all different positions, and I'm not getting a high speed. You know what I believe? I believe this machine is wired for 440 volts, and I'm running it at 220. So I will look into that, but certainly not in this video. Okay, I'm at depth, so I'm climb milling the side, particularly the side closest to my finger here. And that's all I'll just show a little bit of that, but that will clean up that side so it's nice and smooth. Can you see how rough it is away from me? And I will take a light pass over that too to clean it up. Again, climb milling, I'll only show the first side, but you can't really see anything I'm doing anyway. Now can you? Matter of fact, that's all I will show. All right, see how nice and smooth that far side is, but so is the side facing the camera. There is a 1/4 inch tool bit, fits perfectly, just a little bit of slop this way, which I actually want. but I will normally be using a 3/16 and see how nicely, well, of course that's going to fit. What are you thinking, Mr. Pete? And just as predicted, the chips were attracted to the magnet. Well, why wouldn't they be? But it sure is annoying. Okay, returning to the scene of the crime, the tool post is setting on the compound, and here's a 3/16 square tool bit, and it's virtually right on center. So I'm happy up to this point. Now next, I'm going to drill the 3 holes for set screws to clamp the bit into the tool holder. Okay, next, using the Mitutoyo height gauge, I am laying out a line 1/8 of an inch from where my finger is, and it's the center line for these 3 screws. If I can get my fat paws out of the way, all we're doing here is very accurately marking it. You can do that any other way you want if you do not have a Mitutoyo, and get one of these. They cost a fortune, but they are wonderful. Okay, I've laid out the center right there and a couple other holes here. You do not need to know the dimensions. Now I'm going to drill and tap those on the Frankenmill. But let's talk about how I sized these. 1/4 inch would be way, way too large for the screws. Even 10s are way too large, so I selected number 832s because they're in proportion. And at first I wanted to use this type of screw with in other words, a socket head set screw, but the trouble with a small one is that you have to use such a small wrench that you may strip it out. So that's why I'm using socket head cap screws instead of socket head set screws. Too much information. And these are what? 3/4 long, which is a little too long, but that's what I got. And it would be better to have dog point screws, and we won't even talk about why. All right, let's talk about tapping the holes, and this is incredibly important. That's why I'm taking so much time on it. You do not need a thread that is the full depth. You need a thread that is about half the depth. Otherwise, I guarantee you're going to break off a tap. So notice here, there's one of the screws, and it goes in that far without a thread, which is, what, about half of the depth. Now, that's the clearance size. So I'm only tapping a portion of it, and that's all you need. Tapping at the full thickness there will be of no advantage and make it no stronger. So anyway, the smaller tap, the tap drill size, as you can see, goes all the way through for 832, and that is number 29, and the clearance hole through is a number 18 or thereabouts. So there's the 18. So I will be using both of these. I won't show all that, I'm telling you now. Otherwise, the video is already, most people have turned it off, it's so long. All right, this drill bit is the tap drill size, whatever that was. And again, this machine is running way, way too slow. I should go do it on the Bridgeport, but I'm committed here. And now, clean this off a little bit, and I'll go in with the clearance size. Remember about halfway. Don't go all the way through, or you've ruined it, and you will spend the rest of the day pouting in bed. Okay, I'm now going to drill the clearance size hole, and I've set a depth stop for that, and you might see a little black mark on the drill, barely, but you know, it's redundant, so you don't go too deep. You'll ruin it if you go too deep. Okay, this is a 832 tapered tap. Use a tapered tap. I admonish you. Tapered tap. Now, the clearance hole will also help hold the tap straight and true, so we do not need to support it at the top with a spring center or anything like that. And I will tap all the way through until I strike the bottom, being careful not to come in with too much strength and break it off. Okay, I'm on the bottom. I'll back it out and I will repeat that 2 more times off camera, of course. I have always operated an end mill standing over to the right side like this with my left hand on the cross feed and my right hand on the longitudinal feed. And with the Bridgeport, the switch is way over on the other side and quite awkward and annoying. But on the Franken mill, it's pretty much on the center here, so you can use your switch from either side. I really like that. But I'll tell you what I do not like is that I like to use this type of stop, and it will not fit here because of this hand wheel. But to move this stop here clear from the bottom up almost to the top took over 5 minutes, and my thumbs are sore, so I'm not liking that. Okay, I'm tapping the 3rd hole without drama, and I'm just about to the bottom, and my battery did quit a few minutes ago. I hope I didn't lose any footage. So I'll back the tap out, and the holes are done. Thank goodness. No drama, no broken taps. No anger, no tantrums, no pouting. And if you follow my instructions, you can avoid those mental anguish. Never mind. And of course I'll run a file over there eventually and deburr them. I don't want to remove the die yet because I got one more thing to do. Let's move back to the Atlas. I have to take just a few moments here to talk about the T-nut. I'm not going to show you how to make this because I have done that in other videos, but sometimes I do make a little sketch with dimensions, you know, and I did, and machined it to that size. And it's very important here now that this does not stick above the surface. And I used a fine thread rather than a coarse. I thought I had a coarse here. Do you know why? I'm not going to tell you why. But one other thing I want to tell you now that is incredibly important. You must use a bolt that is not too long. This one is too long. So that even after you tighten it up, the screw does not come all the way through. Because if it does, it will strike the bottom of the compound and act as a jack and break your casting off, and that has happened countless times on milling machines and lathes. So you see, if I were to use this one, you see how long it is? And you would tighten and you would tighten thinking, you know, why isn't this tightening up? And suddenly, snap. One more thing to show you. There's always one more. On most commercially made bolt clamping sets, they have staked this. See the little mark there? They have staked it so that you cannot force the bolt through any farther than that, because that's a common problem. That's why you see that. That's free of charge. Now, as I locate the hole for the bolt here, I have modified it, and that's the beauty of making prototypes, because what I found here on this particular compound is I'm not able to turn this any more than that because it's striking the step here. Now, I could shorten this up, I could mill the, you know, there's all kinds of solutions, but my solution is I'm moving the line, the scribe line is the center line, and I've moved it almost 1/8 of an inch down to where my dirty fingernail is, and that's where I will drill a 5/16 hole. I don't think I'm going to show you that because it's just routine, but the hole will go all the way through, and I'll be back presently. Okay, and there it is. It's done, except for deburring. Well, while you were in the bathroom, I very carefully and methodically broke all of the edges and corners so I don't skin my knuckles, etc., ad nauseum, and removed most of the layout die as I could. Now, a couple other things. First of all, I will transfer these screws into the new product, but one other thing here is that we really need a washer underneath the cap screw, and I think you need to choose your washers carefully. You don't want it too thick You don't want it too thin. You want it just right. Okay, there it sits. Now I will have to have a longer bolt, so I will have to cut this one off. This will work, but it doesn't have as much engagement as what I would like. So let me go ahead and install a 3/16 cutter. And we'll take a cut or two here just for the pure pleasure of it. And we'll see how close we are to being on center. And there's just a little interference here between, in other words, I can't use the wrench this way. I have to use the open end part, which is not a big tragedy, but a bit of a failure on my part. Normally I take 2 or 3 prototypes to get it right. How about you? Maybe you're smarter than me and do it in one fell swoop. Oh, and the other thing I wanted to show you here, the only thing I wanted to show you actually, is that by relocating this larger 5/16 hole, I am able to swing it freely. What do you think? Leave a comment if you like this. Give me a thumbs down if you hate it. But then again, most people that hate it are not still watching because this has been almost relentless. Okay, from this view, let's take a facing cut on this 1-inch aluminum. Wow. Perfect, right on center. Okay, my center height is absolutely perfect, impeccable, accurate, so I'm very happy with that. Now I'm not going to take any more cuts because that's not the purpose of this video. Much of that will appear in future videos. But what would I do if I was above or below center? When I ground this tool the other day, I was very careful to take nothing off of the top. So in other words, all my angles met at the ground top of the tool bit from the factory. But if I was below center, I would shim it up. Now I own probably 25 of these, so it's nothing for me to sacrifice one. But since this is a tempered steel, it's kind of hard to cut. You're better off with brass shim stock, and that would go under the tool to raise the tool a little bit. Yeah, it's a pain in the neck. I absolutely agree. So grind your tool very carefully so that doesn't happen. Now, if you're over center, above center, why just take your tool to the grinder and remove just a little bit off of the top rake angle until you get it just right. Now, I would be the very first one to say, how many are going to actually make this? Probably one in the entire world, but you can make one for whatever size your lathe is, and I think you would find it quite useful. But even if you do not, there were, I think, many little operations and details and things that I showed you that are useful in your machining life. So again, if you like this, give me a thumbs up and leave a comment, even if the comment just says, a thumb up. Or if the comment would say, I live in South Africa, or I live in Prussia, I live in Czechoslovakia, or other countries that no longer exist. This is Mr. Pete, your YouTube shop teacher, saying this is one of the most enjoyable videos I did in a long time, but I'm looking at the clock and I've been working at it for 4.5 hours, but I probably got about 4 or 8 hours even in it for all of the initial experimentation and sizing and prototypes and all of that other nonsense. Now, there'll be no pictures at the end because I know people hate that, but I will see you in my next video. I hope. So long for now. This is Mr. Pete.